The last piece of graphing technique that we're going to talk about is how to graph sine and cosine functions where we have a horizontal shift. And horizontal shifts are called phase shifts. All right? And so on most of the work that you're going to be doing, you won't see something that says horizontal. It'll specifically say see phase shift. And that is based off of this bx plus c that you have sitting here next to the trig function. All right. So the phase shift includes the period adjustment as well. And so what it does is the period adjustment right here will squish your graph inward or stretch it outward. And then this plus c will either take all those coordinates and move them all to the left or all to the right. All right. And so when you're dealing with trying to identify what your phase shift is, right, you're going to take the bx plus c and set it equal to 0. And you're going to solve for x. All right, and when you solve for x, what it's going to do is if you have x equals a positive value, that means that you're moving to the right, whatever that number of units is going to be. And when you have x equals a negative value, it's going to tell you to move to the left that many units. All right. Also, when you are solving for x, the order of operations that you use to solve for x is the order you're going to make your adjustments to all of your x values. So for example, let's try graphing y equals the sine of x plus pi over 2. Right. We'd still like to identify all of our key aspects here. And so our amplitude, period, domain, range, midline. And now we also have to add in a new one, which is our phase shift. All right. So something extra, just one more piece. All right. So in your amplitude, again, that's always whatever number is sitting right here in front of your trig function. It's the absolute value. So my amplitude here is going to be 1. My period is always based off of the b value. And here my b value is also 1. And so if I take 2 pi and divide it by my b value, that means that the length of my interval has not changed. I don't know anything yet about my domain and range. I'm going to wait on that for a second. And my midline, I have no plus d. So you can see that there's a difference between having values inside the parentheses and something on the outside. And so you really want to be able to match up the bx plus c being inside parentheses and your d value being after the fact. So in this case, my midline is going to be y equals 0. And so to find my actual phase shift, I need to go through this process of taking the bx plus c and solving for x. So if I take x plus pi over 2 and set it equal to 0, I'm going to subtract off that pi over 2 and move it to the other side. And I get that x equals negative pi over 2. And what that means is that my phase shift means I'm moving all of my x coordinates to the left by an increment of pi over 2. Right? And so let's make an in-out table so we can see what those look like before we try to make our graph. Okay, so when you've got something that's in this form, you can still use x or you can use theta. Okay. And so my output here is going to be y equals the sine of x. Okay. And what I want to do is I want to look at how this is going to be affecting my theta. So anything that's happening on the inside here happens to this theta right here. It doesn't happen to the actual output. It happens to your input. So whatever this value is right here, when you solve for x, that's what you're going to have to do to every single one of your inputs. So right here where I have my theta, what I need to do is I need to take these thetas and I need to subtract off pi over 2 from each theta. All right? And so I'm going to actually shift over my input values way over here. All right? So my normal input values that I have when I'm trying to graph. Right? And so for these 5 input values, I need to now subtract off pi over 2 to get my new placement. Right? And so this is again where adding and subtracting fractions is going to be important. You don't have to go fast, you just have to know how to do it. So 0 minus pi over 2 now shifts this to a negative pi over 2 on the graph. Pi over 2 minus pi over 2 is 0. Right? And then I'm going to get pi over 2. I'm going to get pi, and then 3 pi over 2. And the main thing is that you also want to recognize that the gap between each of my x values is exactly the same. They have a difference of a half. So from negative a half to 0, 0 to half, to 1, to 1.5. And now my output values, because I have no change in amplitude or vertical shift, the normal output values that I would have for my y function or my sine function are also going to already be there. So I'm really going to be plotting these points. All right, these are my in-out coordinates. So for my domain, you can see now my domain has changed. It's going from negative pi over 2 to 3 pi over 2. My range, though, did not change. So shifting everything to the left did not change the placement of my y values. Right. And so now we're going to make a graph. Right. So our graph doesn't need to be very tall, right? But it does need to account for some values now on the left side of the graph where it didn't need to before. Right. So now I need a spot over here at negative pi over 2. Right. And again, I want to make sure that these are nice and evenly spaced so that way my graph looks reasonable. And again, up here is 1 and negative 1. So I want to show you what was really happening. So let me graph the old sine function. So the basic parent graph sine function. In a basic parent graph, right, the function looks like this. Right. So this is my basic one. I'm going to do this in a different color. Right. So that's your sine graph for the parent, all right, starting at 0 and going to 2 pi. Now if I'm shifting all of my x values to the left by pi over 2, now this coordinate has moved here. All right. All these coordinates have now moved to the left by an increment of pi over 2 and then be redrawn. All right. So I haven't changed my stretch. My length of my interval is still the same. It's just that everything has been moved to the left by pi over 2 increments. And that's what the phase shift does. All right? And so what you're going to recognize is that when things are happening to the x values, if there's something in front of the x, for the period, it's going to be the reciprocal. If it says adding, it's going to be subtracting. So you're always going to be doing the opposite operation of what is being attached to your x values. Okay. So let's look at one more. All right, let's look at like a cosine function. All right, so let's do y equals the cosine of x minus pi. And then we're just going to mess with the phase shift for these first 2 examples. I don't want to do a lot of adjustments, but we will do some, again, that will require us to do all of the operations. But let's just focus on the first 2 examples being phase shift. Right, so again, I'm just going to highlight this part that is dealing with the phase shift. Right. So my amplitude is 1. Again, period is 2 pi divided by 1, or just 2 pi. Midline is going to be y equals 0. And for phase shift, again, I'm going to set this equal to 0 and solve. And so, again, you don't necessarily have to show that operation. You know if you're going to add it to the other side, it's going to change the sign. And that means then I'm moving to the right by pi units. Okay. So again, I'm going to actually give myself more space this time for my theta. All right, so y equals the cosine of x. So normal theta values, 0, pi over 2, pi. Okay, so do your normal theta values and your normal cosine values. And again, to this theta, I want to this phase shift. So I'm going to add pi units to all of these outputs. So when I add pi, it now moves everything over by a good amount. All right, still moving them over by the same increments. All right. So if this is pi, now a half plus 1 is going to be 3 pi over 2, 2 pi. All right, 1.5 and 1 is going to be a 5 pi over 2, and then 3 pi. All right. So again, our vertical, or our y-axis doesn't need to be adjusted too much, but this x-axis will. All right, and so I'm going to do a lot of labels. So these have a lot of halves in there. And so what I'm going to do is I'm actually going to put those halves on there for you. I want to show you what that looks like. So half to 3 pi over 2, 2. So that's going to be 1, 2, 3, 4, 5 of the pi over 2s. And then that's going to be 6 of the pi over 2s. And so every time you have a half, you can label every half. And again, the old cosine function, all right, I'm going to label what that looked like so that way we can see how this changed. Okay. But our new placement now starts here. All right. And so again, everything is still the same gap, just moved over a little bit. And so that's my new cosine function where I have a phase shift to the right of pi increments.